Hello everyone. This is the last video this week, and in this video, I'm going to talk about the security market line. So, from our so far understanding in this chapter, we are now in a position to see how risk is rewarded in the marketplace. To begin, suppose that asset A has an expected return of 20% and a beta of 1.6. Okay, and the risk-free rate is 8%. Notice that a risk-free asset by definition has no systematic risk. Okay. Now consider a portfolio made up of asset A, okay, asset A and risk-free asset. Okay, we can calculate some different possible expected portfolio returns and betas by varying the percentages invested in these two assets. For example, if 25% is invested, okay, 25% is invested in A, and the remaining 75% is invested in the risk-free rate. And don't forget that expected return of A is 20%. Okay, expected return of A is 20%, and expected risk-free rate is 8%. So you will see that the expected portfolio return will be 11%. Okay, and the beta of this portfolio will be 40%. Why? Because the beta is beta of A is 1.6. Okay, 1.6, and since risk-free rate doesn't have any systematic risk, so systematic risk is 0 for the risk-free rate. So beta of the portfolio will essentially be 1.6, which is the beta of asset A, and its weight 0.25, right? So the beta of the portfolio is 40%. Now, notice that since the weights have to add up 1, the percentages invested in risk-free asset is equal to 1 minus the percentage invested in asset A. Okay, so one thing that you might wonder about is whether it is possible for the percentage invested in asset A exceed 100%. The answer is yes. This way, the way this can happen is for the investor to borrow at the risk-free rate and invest in asset A. Okay, so that's also possible. And in this case, expected return of the portfolio and the beta of the portfolio will change. Okay, given this discussion, the security market line comes in the picture as it represents the market equilibrium. Okay, market equilibrium, and the slope of this SML line is the reward to risk ratio. Okay, and reward to risk ratio, the reason we discuss this beta expected return to calculate this reward to risk ratio. So reward to risk ratio is expected return on the market minus risk rate divided by the beta of the market. Okay, so that is the reward to risk ratio. Now, if you look at this is the graphical representation. Okay, so this blue line essentially is the security market line, where you have asset beta here and expected return here. Okay, so as I already indicated, that slope of this straight line is the reward to risk ratio. Okay, reward to risk ratio. For example, if you want to calculate the slope of this line, given the information we had, expected return of asset A, for example, is 20%, and risk-free rate is 8% divided by beta of the risky asset was 1.6. So slope will be 7 point. Slope of this line will be 7.5%. Okay. Now, what this tells us is that asset A offers a reward to risk ratio is 7.5%, and asset A has a risk premium of 7.5% per unit of systematic risk. Okay. Now, look, this security market line is important, because at any point of this security market line, these will tell you that for a given level of beta, how much the reward to risk ratio is provided by these assets. Okay, and whether that provides sufficient compensation for the systematic risk. Okay, now suppose we consider a second asset, for example, asset B. This asset has a beta of 1.2, and expected return of 16%. Which investment is better, asset A or asset B? You might think that once again, we really cannot say. Some investor would prefer A, some investor might prefer B. Actually, however, we can say, okay, A is better because as we demonstrate that B offers inadequate compensation for systematic risk. Okay, inadequate compensation for systematic risk because if you calculate this reward to risk ratio in the similar fashion, you will find that its reward to risk ratio is less than that, which means that A is preferable than B because A provides higher compensation or B provides insufficient compensation for the systematic risk. Okay, so if you calculate the reward to risk ratio of B, you will find that it is 6.7%. Okay, so between A and B, A is preferable as it provides higher compensation for every unit of systematic risk. Now, we will very briefly talk about the capital asset pricing model. Look, if we let expected return and beta stand for what we are expecting from a portfolio and its systematic risk, on any asset in the market, then we know that asset must plot on the security market line, right? On the security market line. As a result, we know that its reward to risk ratio is the same as the overall market. Okay. And if we rearrange the equation that we have seen previously, then the equation comes this, that expected return equals to risk-free rate plus risk premium into beta. Okay. So this equation is called the capital asset pricing model. Okay. What the CAPM shows is that expected return of a particular asset, depends on three things. One is the pure time value of money. Okay. As measured by the risk-free rate, this is the reward of merely waiting for your money. You don't take any risk, but since if you invest, your money loses your purchasing power, so you just get reward for the time value of money. Okay. The second component is the reward for bearing systematic risk, which is this. Okay, and you can see that this is the expected return and this is the risk-free rate. Now this is expected return on the market minus risk-free rate. So this is market return minus risk-free rate. So what is the compensation you receive for taking the systematic risk? So this is called systematic risk premium, or this is the reward the market offers for bearing an average amount of systematic risk. Okay, now you understand that this component will be same for all stocks. Why? Because expected return on the market and the risk-free rate is same. However, expected return will vary stock to stock because of the amount of systematic risk. So this beta is the amount of systematic risk that is present for this particular stock. Okay, so which means that look, so this is the risk premium for an average systematic risk, and now higher the beta, okay, higher will be the expected return. So you see that this expected return across the stock will vary only for this component because all other will be the same for all stock. Okay, so higher systematic risk will result in higher expected return. So if you remember, we discussed it previously that for a diversified portfolio, you only can expect to be compensated for taking systematic risk. So no compensation for unsystematic risk. So these are the points that I have just discussed. Okay, so this is the end of our discussion about security market line and capital asset pricing model, and this is the end of this chapter 2. So if you have any question, any problem with any of the topics, don't hesitate to let me know. Okay, so thank you very much for watching.